Woohoo, welcome back. My Martian friend and I are here again for more derivative fun. Woohoo! This time we're going to be doing the second derivative. Woohoo! Dance party for the second derivative. Okay, so for the second derivative, notice that you can either write f with two of those primes there, which I just use apostrophes. Technically, it's not an apostrophe. It's this amazing little thing that looks like a little wedge shape, almost like we're doing cuneiform. And but we use apostrophes because when we're typing it out on a keyboard, we don't have the wedge-shaped guy. So this is called second derivative of f, or f double prime is what I've heard. You can also write 2 in little parentheses. Now, I understand this can be very confusing because it looks like an exponent, but in the parentheses like that, it means the second derivative. And basically, we're going to use the same method we had been using. We're going to use the definition of the derivative. As h approaches 0, take the difference between the first derivative at x plus h and at x and divide it all by h. So in the last video, we discovered, dun dun dun, that f prime of x was equal to, what was it? That is a good question. Oh, there it is. It was 12x squared minus 4x plus 3. Sorry, my little Martian friend. And so first thing we got to do is find f prime at x plus h. And remember, if we're using the same colors, the plain one last time was red, and this one is going to be our fancy one with x plus h, where we plug that in. That's going to be blue. And so what we do is everywhere there's an x, I'm going to put in an x plus h. So we've got x squared becomes x plus h squared, 4x becomes 4x plus h, and 3, well, just 3 is hanging out, so 3 just hangs out. Okay, so this is going to be 12 times, and hopefully by now you have it memorized. If not, either use FOIL or the formula for the square of a binomial, or use Pascal's triangle, which I talked about in the previous video. I just have it memorized at this point. So if you want, I mean, one technique is to become a math teacher for 30 years, and then you'll know it. But that might take more time than you really want to put into this class. So it's up to you. So then I'm going to use the distributive property, 12x squared plus 24xh plus 12h squared minus 4x minus 4h plus 3. Take a look at that. Okay, now, usually when we expand this, when we multiply this all out, nothing's going to cancel. So that's just going to be our big ol' f prime at x plus h. And then remember what we have to do. We have to find the difference quotient of the difference between f prime at x plus h minus f prime at x, all divided by h. And then first we'll have this long one. Oops, hopefully I left enough room. Fingers crossed. And then we'll do the little short one. Hopefully I have the original, the OG minus 4x plus 3. That's the red one. That's the plain version. And then put the whole thing over h. So this is going to be the fancy version. The 12x squared plus 24xh plus 12h squared minus 4x minus 4h plus 3. Look at that. I fit it all in. Woohoo! Martians are very impressed. Martians, fun fact, Martians are really good at space saving because their planet is so much smaller than ours. So they don't have a lot of room. So they're very impressed when you can get a large amount of stuff into a little tiny place. So thank you. He's giving me kudos. He's waving. He's very excited about math. Having 6 fingers, they do everything in I can't think, base 6, there's the word. They do everything base 6. So their math looks really different. So he's very excited about this base 10 stuff. Okay. I'm going to write this out. Remember that the first one, the fancy one, the blue one. Ooh, I forgot to write. This is the red one there. There we go. The fancy one, the blue one, is the long one. It's what happens when you put x plus h in. So I got 12x squared plus 24xh plus 12h squared minus 4x minus 4h plus 3. Now for the second one, remember this minus goes multiplying through times everyone, so it changes all the signs. Minus 12x squared plus 4x minus 3. Changing the signs is what allows us to cancel. Oh, let's see, there's the minus 4x plus 4x and the plus 3 and the minus 3. They all cancel out. And then we get 24xh plus 12h squared minus 4h all over h. Woohoo, a lot shorter than the previous one, huh? Now, remember, I want to cancel h. I see h in all of these. Oops, sorry. I see h in all of them, so I'm going to factor it out. I get 24x plus 12h minus 4 all over h. Cancel the h's, and I get 24x plus 12h minus 4. So an interesting thing I'm noticing is in each step, I'm losing 1 degree. Our original function was a cubic, x cubed, and then our first derivative was a quadratic, which is x squared, not a quartic. Sorry about that. And then x to the first. So it's really interesting. It seems to be diminishing by 1 power every time. Now, this is not the derivative. This is the difference quotient. So our second derivative is going to be what happens when we take h to 0 of f prime of x plus h minus f prime of x all over h. So that's the limit as h approaches 0 of 24x plus 12h minus 4, which I think you can already see. That's going to be 24x plus 12 times 0 minus 4, and that middle term is going to just cancel out. So we get 24x minus 4, and that's the second derivative. Oh my gosh, are you guys excited as I am? Woohoo! Woohoo! Yay! Martian's excited. Woohoo! Woohoo! Okay, so now what? Well, the problem said it wanted us to keep going, so I'm going to go ahead and keep going. Let's go ahead and look at the third derivative. So the next one is, see, we got 3. Now, at this point, I think you can guess that writing out 3 apostrophes looks a little funny. So a lot of people do just use the parentheses with the 3 inside to mean the third derivative. This is the third derivative. And so we want to take the difference quotient of the second derivative. So what was the second derivative? The second derivative was 24x minus 4. Okay. So then what do we have to do? We have to take the second derivative of x plus h. Now, at each level, this is getting way easier, right? Because we're just going to take whatever was x, and now it's going to be x plus h. And we don't need any fancy tools for this. This is just going to be 24x plus 24h minus 4, right? Woohoo. So it's funny because a lot of times in math, if you keep going, things get harder and harder. With derivatives, frequently they get easier and easier. So we want to look at the limit as h approaches 0 of the second derivative at x plus h minus the second derivative at x all over h, right? And this is going to be our plain version, which is this guy. And this is going to be our fancy version right there, which is going to be this guy. And this is going to be the limit as h approaches 0 of the fancy long one minus the quick short one. And some people are going to ask, why are you doing it like this? Why don't you do the difference quotient first? And I said, well, this one is short enough that I can just kind of do it all at once. If you want to do it in 2 parts like I did the previous 2, that is great. You should do it that way. You can do it either way. So this is going to be 24x plus 24h minus 4. And this is going to be the original plain version, 24x minus 4. So we get the limit as h approaches 0 of 24x plus 24h minus 4. And now I'm going to subtract each of these, minus 24x plus 4. And then we go, oh, the 24x and the minus 24x cancel out. The minus 4 and the plus 4 cancel out. So all we've got is the limit as h approaches 0 of 24h over h. Now, if we just plug in now, we're going to get 0 over 0, so that's no good. But if you remember, we should go ahead and cancel the h's. Then we've got the limit as h approaches 0 of 24. Now, for some people, this is the hardest limit of all, because it's like, well, what does that mean? So I would say, what happens to 24 when h becomes very, very small, turns into 0? And the answer is 24 is just 24. It's a constant. What happens to 24 when h goes to Mexico? Same thing, nothing. 24 is 24. What happens if h has a big party and has ice cream sundaes? Does not matter. 24 is a constant. It stays 24. So the limit as h approaches 0 of 24 is 24. So our third derivative is 24, which is kind of interesting. So let's do the fourth derivative. Woohoo! Why do I sometimes capitalize and sometimes I don't? I don't know. I don't know. I think it's whimsy. So, fourth derivative. I got to be honest. I wrote this out. It made me giggle. This is what mathematician thinks is funny. No one does this. By 4, certainly if not by 3, but definitely by 4, you're no longer just, because it would just be so mean, like the 10th derivative and just write 10 and have everyone have to count it. So we don't do that. When it stops being obvious, like after second or third, you go ahead and write it in. So don't write it like that. I just give you an example. But basically we want to take the third derivative and do the same thing, difference quotient limit. So this one is also can be really challenging because a lot of people, they're like, well, what's the third derivative at x plus h? Because that means everywhere there's x, we replace it with x plus h. And the answer is 24 is 24. X plus h, x does not matter. It's 24. So our regular plain one is going to be 24. And our fancy one is also going to be 24. Now, those of you who are thinking ahead, you're like, wait a minute, this is going to cause a problem. And the answer is yes, if you rush. But let's not rush. Let's just take it step by step. So the fourth derivative of x at x is the limit as h approaches 0 of the third derivative at x plus h minus the third derivative at x all over h. Okay, so this is the limit as h approaches 0. Do not panic, because I see people, I can see you through the screen. Some people are panicked. What happens when we take the third derivative at x plus h? It's 24. What happens when we take the third derivative at x? It's 24. Now, a lot of people are going to go, it's zeros and zeros and zeros. And the answer is chill. Gently. I'm going to say chill, because a lot of times in math, we got to chill. So do not take the limit. Leave the limit undone. What is 24 minus 24? It's 0. Okay, do not panic. I see some people panicking. Through my magical YouTube studio video taking magical powers. And in fact, even my Martian is starting to panic. It's like 0 over 0, 0 over 0. Warning, Will Robinson. I'm like, oh, did you watch that show too? Yeah. Okay, so do not let h go to 0. Do not worry about the limit. Worry first about 0 over h. Now remember, h is not actually equal to 0. H is moving towards 0, but it's not actually equal to 0. So 0 over h is just 0. 0 over h is just 0. And what's the limit as h approaches 0 of a constant? It is that constant. So the fourth derivative of f at x is 0. Woohoo! We did it! Yay! We did it! I'm going to start singing the Dora song if I'm not careful. So that's the fourth derivative. You survived it. Congratulations. My Martian friend and I are going to go do some dancing. And we're going to have a big old party because we finished explaining, hopefully, the definition of the derivative. Again, I want to encourage you to be really gentle with yourself because this stuff is not obvious. It's not easy. This has challenged folks forever. And so, well, at least for, 500 years. So, be really gentle, ask lots of questions, ask me lots of questions, ask the tutors lots of questions, do lots of practice, and know that in the future, the very near future, we're going to have shortcuts and we're not going to have to do the difference quotient anymore. Woohoo! Yay! So go out, touch grass, get some sun or some rain or whatever's out there. Well, not a volcanic eruption. No, that would not be good. So if there's volcanoes erupting, please just evacuate. But like if there's just rain or sun or maybe a little bit of snow, go out and get that. Enjoy yourself. Take a break. Take a little rest. Get some snacks. And know that you're awesome for getting through this. And woohoo and math on.